Okay, so we looked at the basic analysis of doing a function using a function y is equals to x. Now there is a formula that's used for linear functions. A linear function is just a simple straight line like what we had. So basically if this is your y-axis and this is your x-axis, this is a linear function. It's a straight line. And the same applies to that. Is a linear function. It's a straight line. Now, linear functions are expressed by y is equals to mx plus c. X is independent. X is the one that's going to determine y. Right? Y is a constant, meaning it is, c is a constant, meaning that's what y is even if x is 0. So let's take an example. If x is equals to 0, then this function that we have will be m times 0 plus c, and then y will be equals to c. Right? Now that means that where x, if x is equals to 0, then y is equals to c. This is in the expression y is equals to mx plus c. So it means y will always have some value, which is c, even if x is not there, because anything times 0 will take this whole thing away. Right? Now if we go back to it again, y is equals to mx plus c. M is the slope. It's the gradient. M is the number that determines how flat or how steep the graph is. So if we have y and x, this could be y is equals to mx plus c, right? M in this particular case would determine whether this line goes right at the beginning here, in the middle here, or it's flat like that, or it's steep like this. This number m is the slope. It tells you how flat or how steep the line is, which also tells you the relationship between y and x. Because if, for example, you have y axis and x-axis, and the line is very steep like this, this line tells you that you can change y by this much, but x will change by a small margin. Very small margin. But this is much bigger, right? So this is y1, y2. So, but if it was flat, y-axis, x-axis, flatter like this, it means that a big difference in x could mean a relatively small difference. There's a big difference here in x, but there's a relatively small difference here on the y-axis. Now, all of that in this equation is determined by this number. This is the number that determines how flat or how steep the line is. It also determines the relationship between x and y. So if it's flat, it will tell you that you can change this by a little bit, and this will change by a lot, or the other way around. So it actually is determining the relationship between these two, while c, the constant, is a number that tells you that even if x is not there, y will be something. The y will not be 0. Now let's go back to our example of y is equals to x. If you write this in terms of what we've just spoken about now, it actually is y is equals to mx plus c, where m is 1 plus c is 0. So this became just x, because 1 times x is x, plus 0 still remains as x. So you can still write it out as the same function as y is equal to ms plus c. So most linear functions can be written in this particular form. Now it doesn't matter if that linear function is with regards to y and x in mathematics, or the linear function is regards to quantity and price in economics. The same rules apply.